it's Nick from Catskill Customs here in upstate New York. I got a cool project in the shop right now, I thought I'd share it. This fender I just pulled off of a Mitsubishi J54. Basically what that is it's a Willys Jeep. Willys licensed the design of Mitsubishi, so Mitsubishi can manufacture them for the Japanese military. And this one is right-hand drive, and it has a 4-cylinder, I believe, Mitsubishi diesel with the PTO winch on it. It's really cool. So what I'm going to be doing on this fender is making it look more like the Willys version that we're used to seeing. The difference in the fender is the Willys have a radius corner right here, not squared, and the Willys doesn't have this front kick down. So this side radius actually flattens out, it runs around a rounded corner, across the front, and then sits flush with the grill. I have my patterns from last time, so you can see, give you a better idea. So this is where the new radius will be. So I'm going to start off by trimming the fender right around here, and then get in the power hammer, start shrinking down a lot of metal. I need to really shrink a lot in here to get this radius to come around. We'll see how it goes. Okay, I've got the fender cut, paint stripped, and I've got some of my lines marked out here. I made some marks where my radius ends on each side. I don't really need to shrink past that part. I'm actually going to taper out my shrinks a little bit as I get there, and I'll sort of creep up on it. Because I only need to shrink where this radius is coming around. Once I get this radius down, once I get the metal on the radius down and coming around, then this should just fold straight down, and then I can hammer and dolly it to shape. Same thing on this side. I don't need to go past where the radius is my shrinks. I just need to get this corner down. So I'm going to start. These triangles represent my shrinks. I'm going to shrink deep into this corner. I probably don't even have to take this corner out. I could just go straight to the hammer with that. And I'll just keep working, and I'll check my progress by pulling this down and checking my radius out. I've done a round of shrinking in the corner, just quickly planished it so we get a good look at what's going on. I tapered out over here. You can see it's rounding around well. However, this section still doesn't want to drop down. So what that means, I have to shrink some more in this area. There's still some material here holding it up. Once this comes in, this will drop down almost on its own. And then as a result of this dropping down, this whole corner should probably come down a little bit more too. So I'm going to do another round of shrinking in this area, and maybe a little bit down low here just to help it come down. And I think that'll give it close to where I need to be. Okay, a little more shrinking, some planishing, and it's looking good. This is going to line up flush with the grill. I need to do a final trim over here along the support bracket. I've got a little ripple right here, which is really a pain because there's a support bracket that runs on the underside here, so I can't get a tool really behind there, and I don't want to trim away any more of the support bracket. So that's going to be a little tricky. If you take a look at this top radius, that's dead on. It's looking good. A little hammer and dolly work just to clean up that edge, but that's no big deal. I do have one little problem that's kind of interesting, is everything sits flat and level right through here, but then right in this section, it kind of flips up just a touch. I mean, maybe a 1/16. What that means is we have to do a little shrinking over in here. So I did some more shrinking in this area, right down along the bottom here and a little bit deeper in this section. And what that did is that pulled the material like this. So this section pulled in. And what that did is made this area want to come down. So after doing that, I was able to planish up in here, which allowed this top surface to drop down. So now I'll just go through a little bit more hammer and dolly work just to clean up this edge. But that's all that's needed there. You can see in this area, maybe the camera picks up, there's still a little bit of dimpling in here. I mean, maybe a thousandth or two deep from the shrinking die. I could definitely get that out. I mean, this material is so thick, you could even DA that out, but I have a nice thickness of material through here. I don't want to take any away because then, you know, less materials, less structure, less strength. So I'm just going to leave that as it is. This is getting painted, so no big deal. Next, I got to cut out a triangle for here. This is an area where from the factory, the material was overlapped and seam welded. It's a real good place for us to start. And besides, I couldn't do anything with shaping that. So I'll cut out a new piece there, weld it in and planish it, and then turn this flange along the bottom, and this fender will be ready to go. Okay, change of plans. Sometimes you hit speed bumps when you do this kind of work and you gotta regroup. I got this triangle section over here welded in, no big deal. When it came time to do the flange along this radius, that turned out to be a real nightmare. I had already shrank this material a lot to get this top radius in. All that original squared off material had to shrink down and come in. So it started off as 16 gauge steel, got thick. Not to mention the steel that Mitsubishi used on this is really hard stuff. It doesn't like to move. So I did end up getting that flange turned by hand. And it really sucked because I can't fit any machine in there. I don't have a very good shrinker. It struggled with that material anyways. But there's support brackets under here. And once that flange started getting tipped a little bit, my shrinker would no longer fit in there. So I did everything by hand, tuck shrinking, hammering that flange around, and I got it. Here it is now, cut in pieces. That was that flange. But ultimately, I wasn't happy with the way it turned out. It was good enough. You know, it could have been body worked without a crazy amount of filler or anything like that, but I didn't want to turn out good enough work. So, regrouped, and this is the way I decided to go about it, and this is really the better way of doing it under these circumstances. Got a fresh piece of 16 gauge here, bent it in the break so I have a nice radius along the bottom, nice clean flange edge, and then I was able to use my shrinker, work the radius around and get a nice tight fit. This is sitting on here with a slight overlap, about a 1/4 inch, but you can see just one clamp holds it right where it needs to be. Whenever you're putting in a panel like this, that's how you want it to fit. You want it to fit well without force. You don't want to have to clamp it hard into place because once you start to weld and put heat into it, it's going to want to move all over the place. So I got it set up nice. I took these dividers over on the existing fender section, and you know, each point's about middle radius of the two lines. You know, I got middle radius, and so on. So the edge is right where it needs to be. I also put my new seam right in the middle here of this face so I can get in my planching hammer without a problem. So once I weld that in, I'll put in the hammer, I'll planch it out, that weld seam will disappear. We'll have a much cleaner, better finished product than doing it all by hand. You know, that's time I lost. I can't charge a customer for that, but live and learn. And then when I go on to the other side, this is how I'm going to do it from the start, and it's going to be faster, and it's going to be a better finished product. So I'll scribe a line, I'll carefully trim it to get a nice tight fit, tack it, then seam weld it, planch it out, and we'll see how it looks when it's all done. Okay, I've got this panel finished up. It's a metal finish to where it needs to be. This is a good example of a paint quality finish. You know, it's nice and smooth, but it's not perfect. It's got some rippling left from the hammer, some tiny low spots here and there. You get to a point where it's not going to benefit anyone by going further. You know, if you have a customer with a panel that's going to be painted and they want a perfect finish, they want a perfect no filler panel, and they're willing to pay for it and wait the extra time, then I mean, that's great. Everyone who does this kind of work loves that thing. We all want to make perfect panels. But, you know, for something that's going to be painted, I try to get it to where a couple of coats of primer and a block sand and it's ready to go for paint. You know, sometimes you get to areas like right in here, I got a bracket behind it, I can't really get that low spot up. It might need some filler, you know, under 1/16. that's fine. You know, you see on TV, a lot of guys will go behind here and they'll hammer up the low spots, and then when they're done, they get the angle grinder out and they grind over the whole thing. And on TV, it looks great, especially with the rough finish that the angle grinder puts on it. It hides all the imperfections. But also, too, you're thinning out the metal. If you bump up a high spot then grind it down, you're just making thin spots. And I'd rather have filler on the panel any day than a bunch of thin metal. You know, metal different thicknesses all through from grinding it off. So this fender's done. I'm going to get to work on the next one. I'm going to do this corner the same way. I'm happy with the way this came out. It's got a nice radius down here. My flange turn is nice. It matches the rest of the fender. So I'll get going on the next one. I thought some viewers might be interested in seeing this part of the process. Now that I'm done with this fender, I'm making a pattern that I can use on the other fender to make sure I get them symmetrical. While making this pattern though, it's a good visual representation of how much shrinking actually needs to go in to making this radius from the squared off fender we started with. So if you look at these folds in the paper, each fold represents an area of shrinking. And you can see there's a lot. So when I lay this out now on the other fender, I can lay out this pattern and I'll mark these areas where I need to do the deep shrinks. Now when you're using a power hammer, pretty much anything that shrinks, you have to remember you can't just do these deep shrinks, because as this pulls in, the metal down here is going to want to bunch up because it's not shrunk and these spaces in between. So I'll run long shrinks, and then in between the series of the long deep shrinks up to the radius corner, I'll do shorter shrinks right here in the middle, and that'll help bring this down. Alright, here's the finished product. These fenders got 2 coats of primer, a block sand, another coat of primer, and then the top coat that's on them is just some rattle can paint that the customer found that was somewhat close off the shelf. I believe the plan is he'll bring this to a painter to have them professionally sprayed at some point, but this will keep it safe for now. Thanks for checking out the video. Hope you learned something, and I'll see you in the next one.